Dear students, let us continue our learning on the course Data Structures and Applications. We are in the first session of the fourth topic of the module 4. The topic is on files and its organization. The topics covered under this session are data hierarchy, file attributes, and text and the binary files. Myself, Dr. Suresha.D. from the Department of Computer Science and Engineering of Canara Engineering College, Bantwal, Mangaluru. First, we should know what is a file and the difference between the files and the directories. Right? So if we take one simple example, so this is the directory what we are using. So in this directory, let me take the directory as M4L8. So in this directory, as you observe, we have the subdirectories. In the meantime, we have some files over here. The files will actually hold your data. The data can be, and it can be in PPT like this, or it can be in a Word file, or it can be in PDF file. So these are the data what we are having. Along with the data, the directory may have the subdirectories. Files will have the data wherein the directories may have the subdirectories as well as the files in it. So there is a main difference between your directory and the file. So directories, we also call them as the folders in the Windows. So in the Windows, we call the directories with the name as the folder over there. So folders and the directories, they are the one and the same. Whereas the files can be of a different type, but they are meant to hold your data. So files will actually hold your data, whereas the directory will have the files as well as the direct subdirectories in it. So if we go with the file, so that every file contains data, which can be organized in a hierarchy to present a systematic organization. A data hierarchy includes data fields such as records, files, and database. These are defined as, first will be the data field, a elementary unit. A elementary unit in a elementary unit is used as a data field. Fine. So that is a data field is an elementary unit that stores a single fact. A data field is usually characterized by its type and the size. You might have seen the name of the student. The name of the student, if you take up, that is nothing but a array of character. So name of the student is nothing but the array of the character over there. So name, I can have a size of some 30 bytes it can hold. Then next, if we go with the age, so age will be an integer type. Age will be an integer type. Fine. So that is, if we go with the is a date of birth. So again, it is a structure. So which may have the three fields over there. That is the date and the month and the year. So that comes under record. But a data field means these types, wherein each one is a elementary entity. Elementary means single unit. So such a single unit is called as the data field over there. That is, a data field is usually characterized by its type and the size. Example, maybe a student name is a data field that stores the name of the student. Then next, record. So record is similar to the structure what we have learned earlier, so that it will have different fields which are clubbed together. If we take up address. So if we take up the address, so address will have the different entities over there. So the first may be your street, the first may be door number. So the first may be a door number. Then next you may have the street name. Next you may have the street name. Then next you may have the cross, which cross it is. Third cross, fourth cross. Then the which main it is. Then it may be your area. Then it may be your locality. then you can have the pin number over there. So pin number may be an integer. Fine. So all these fields are to be grouped together and which need to be addressed as a single entity. So in those cases, we call it as a record over there. That is, a record is a collection of related data fields which can be seen as a single unit from the application point of view. Example, the student's record may contain the data fields like a name, address, phone number, roll number, marks obtained, and so on. So similar to that of the structure what we have learned in the C programming. Right? Data field is an individual entity. Data field, if I take up the door number is a data field. It is an individual single entity. But if you go with the record will have the collection of the related data field. Such collection of the related data fields, we call it as a record over there. Then the next, a file. A file is a collection of records. File is the collection of such a record. So that record may be of individual one. So this address is of individual one. So now I want to have the record of all my students. So now we have the 62 students in the class. I want to have the record of 62 students together. I want in one file. So now each student, if I take up, each student is one record. Each student is a one record. So what the student details will be there? So student details may be name is date of birth is phone number is address, right? So now that is, it is nothing but the collection of records. So now if we go with the date of birth, again it may have the three fields over there. That is the date, month and the year. Then next the address, if we go, as I told, address itself is again a record, which we have the sub records over there. Right? But when we make the collection of all 62 students, that will be a file. That will be a step file. That is, a file is a collection of related records. Now it is a collection of students. For in college, collection of employees or the teachers. Or from your point of view, we can say the collection of all the records of the subject data structures. Fine. So wherein you have collected all the elements which you have read in the first class, second class, third class, like that what you have read. Fine. That is, first basic entity is the data field. So now the record is a collection of such data field will be your record. And file is a collection of these records. A file is a collection of these records. We call it as a file. So example, we have stated a file of all employees working in an organization is one type of a file. Right? Next, directory. So now the directory, what it will have, directory is similar to that of the folders. So all the if I take up the directory of the CS department. So now what the CS department will have, will have the data of the first year, will have the data of the second year. So next it will have the data of the third year and the data of the fourth year. So now in the first year, if I take up, again I have the two sections, A and the B section. So now if I go to the A section, I have the 65 students over there, the details of the 65 students. Right? So now that will be a directory. So now what the directory will have, can I club all the unrelated files? No. So what we will do, all the related files. All the related files we will club together and we make a group over there. That group in the Windows, we call it as a folder, but here we use the word directory in the programming world. In our programming, we call it as a directory. That is, a directory stores the information of the related files. A directory will store the information of the related files. A directory organizes the information so that the users can find it easily over there. So one sample example has been given. That is, a directory is having the three components over there. One about is a personal information. Other about is academic information. Other about the fees information. In the personal information, what we are having a roll number, name, address, and the phone number. In academic information, roll number, name, course, marks, and the grade point you obtained. Then next in the fees, roll number, name, fees, lab dues, hostel dues, and the library dues. Right? So each one is a file. So now we combine these files. We are not merging the file. What we are doing? So each file we are creating a directory and we are putting these files over there. Right? That is, directory will store the information of the related files. Right? So these are the entities. The first on the top we have the directory. Directory will have the collection of files. File actually will hold our data. So now what the file will have? It will have a collection of records. Record will have the each single entity will be called as a record over there. Right? Then next, attributes. When we go to the attributes means features. The features for the file. So what are all the features which can be used? File as a list of attributes associated with it that gives the operating system and the application software information about the file and how it is intended to be used. So we seen some of the files, if you remember. A Word file we have seen, text file we have seen, a PPT file we have seen a video file over there. And these are the different types of files. Fine. The attributes will distinguish these features. What type of file it is, what the content might be. All these details will be there in the file attributes along with it. What are all the attributes which may be present? The first one will be the name of the file. Name of the file. That is, the file name is the first important attribute for a file. The name what we are given for the file. So what the file name is? The string of characters that stores the name of the file. File naming convention vary from operating system to the other operating system. Some may not allow a special character to be used for the name of the file, but some may use to have the special characters can be used over there. Right? So those are the about the name of the file. It is the first attribute. The second attribute, the file position. That is, when we go for reading from the file, then I want the third line to be read. So that is, I need to move my cursor to the third position over there. That is the third line I need to move on. In the third line, I want to go at the fifth column onwards. I want to read. That is a that will be regarding a position in the file. That is, it is a pointer that points to the position at which the next read or the write operation to be performed. Fine. That will be regarding the file position, for which file pointer is used. For accessing the position of the file and all, file pointer is used. Then next is the file structure. The file structure I told simple example, that is your text file, Word file, your PDF, your PPT. All of them comes under your text file over there. Means the contents can be readable. The contents can be readable. But you might have seen a exe file has been created when you are going to execute your file. Whenever you are going to execute your file, one exe file will be created. Or if we take up some other example, if I try to open an image file, if I try to open the image file, then how it will look like. Let me go with the more apps over here. So wherein I will use a WordPad, I will open. Fine. So image file I am trying to open in the WordPad. So it is taking a long time. Instead of that one, let us take some other application. Let me take the image file. Open with, and I will try to open with the I will try to open this image file in the Word or the WordPad. So now can we read these contents? Now if you look at the contents over here, the contents are not readable with our bare eyes. We are not able to read the contents. Fine. So it is looking like some boxes, some special characters over there. Means this is not readable for us. Fine. So these are the two categories of the files. That will be a text file, means your Word file, your PPTs, your Notepad files. They are all comes under your text files. And the other category is a binary file. So wherein the binary file, the data will be stored in a binary format, a continuous format it is. Continuously it will be stored. But for the human access, we may fail to extract the contents directly. But we need an application that matches its type, only then we are able to read the contents. That will be regarding the file structure. That is, it can be a text file or it can be a binary file. The next one. file access method. So when we go for the accessing the files, there are two main access methods are there. One is the sequential access, other is the random access. The sequential access is used to extract our data line by line and column by column. First line I am going to read, or in the first line, first column I am going to read, second column, third column. Then once the first line finishes, I will move to the second line. That is, the data can be, you are accessing your data sequentially over there. And one more method is there, randomly we can access our data. So we, in particular, we search for some keyword, from there we are going to access our data. That is, the file access we can be a sequential access, or it can be a random access can be provided. These are the access methods for the file. Then next. In a sequential access method, records are read one by one. That is, if 60 records of students are stored in a student file, then to read the 39th student, first I need to read the first 38 student. Then only I can go for the 39th student. Fine. That is the sequential one. I can't bypass anything. I can't bypass anything. It's a sequential. That is one by one. I need to go for reading the file content. Fine. So that will be regarding the sequential file. A random file that can be accessed anywhere in any order. I can go for accessing. But for the sequential, I should go one by one. I should go and access the contents. Then next, attributes flag. These are the attributes can be any one among them. That is, of the first one will be a read only. Read only means you can just open that one, but you can't change its contents. You can't change the contents. There are 8 bits are there, you can see over here. So each bit is meant for one particular attribute. Each bit is meant for the one particular attribute. Out of which the 6 main attributes we are going to have. Right? First one is a read only. So read only if you make means now the others can't change this one. It is only for the sake of just reading, not writing to it. Then next, the hidden. So if you make it hidden, you can't access, you can't look with just directly looking at the folder. Those files are not visible to us. That will be a hidden file. System file. So if you have designed any IO applications which need to be linked with any of the program, such one we call it as a system files. Label, volume labels. That is the fourth one. Volume label can be C, D, and the E when we use. There, the volume label will be done. Then the directory. So if you want to have a directory file, then the next bit will be used. Then the archive. If you want to use so that idea as a backup you want to store. So archival is nothing but it is for your backup purpose. We are going to use the archival of the file. So for that one, we are going to use the 6th bit. These are the 6 different flags, attributes what we use. That is, a file can have 6 additional attributes attached to it. These attributes usually stored in a single bit, in a byte, wherein the each bit corresponding to a specific attributes. If a particular bit is set to 1, means that attribute is on, or else that attribute is off. Right? So if we go in detail, read only. A file is marked as a read only, cannot be deleted or modified. We can just open that file, we can see the content, and we can exit. If you try to modify the content, you will get the error message as access denied. You don't have the permission to do that one. Access denied. So such a file, so normally what happens is when you create any applications, we used to share the read only file. So that the basic things of that particular project or the app is given over there. Or a key of that file or the app has been given. So you want that file is not to be altered by the other person. In those cases, we can set it to the read only over there. The next, hidden. Hidden means when I open that one directly, I don't want the other people to see that one. So then we make that a hidden file. Then next one, a system file I want to make. A file is marked as a system file indicates that it is an important file used by the system. It is not supposed to be altered or removed by the disk. Volume label. A volume label, as I told you, your hard disk is partitioned into C, D, and the E in those cases. You want to label it. You want to label so that the identification can be done easily. That is your volume label. That is, every disk volume is assigned a label for identification. The label can be assigned at the time of formatting the disk or later through various tools such as the dash command uses the command as a label over there. Right? So these are the additional attributes what we have in the files. To list out, the attributes are the name of the file position, then the file structure which includes binary and the text binary file or the text file, Access method, it can be in sequential or it can be in random access. File attributes, 6 file attributes are there: read only, hidden, system, volume label, directory, and the archival of the file. Then next we have seen the other two, they are directory and the act. So directory means it is not the actual data. Instead, it may have the subdirectories or the collection of the such things. Then the archival. So archival is the communication link between the programs that modify the files and that are used for your backupping of the files. That is, archival is nothing but your backupping up. If you want to have a progressive backup, progressive means every 30 minutes I want to have a backup, or every 50 minutes I want to have a backup, or every day I want to have a backup. You might have seen in your WhatsApp also, you might have seen. When do you want to have the backup? Never, one day, 1 week, 1 month, like the different options will be there. So that is nothing but your archival of the files. Your data, what you have received in your WhatsApp, you are going to store that one to your secondary device. So for those cases, we make the file attribute as the archive. That is for your backup. And incremental backup means it will be next one week later, next backup will be created, old backup is discarded. That is your incremental backup. So these are the 6 different additional attributes for the files. Next one will be the types of the file. So when we go to the files, there are two different categories are there. One is the text file and the binary file. Before going to the files, let us look how the data is actually processed in the system. Suppose in my keyword I have typed a character A, or I typed a character 0. That is what are all the characters we use, either capital A to capital Z, or small a to small z, or 0 to 9. Along with that one, we may have some special characters are allowed. And the question is, does the mission knows these A, B, C, 0, 9 and all? No. It knows only the binary language. It doesn't know any other language other than the binary. So now we are able to convert our input, means our data, what we are understanding. So now there is a gap between our what we understand, what the human understand, and what the machine understand. So what the human understand on the other side, what our machine is nothing but our computer. So what the computer will understand on the other side. So machine knows only the zeros and the ones. But we are not perfect in writing the things with the zeros and the ones. We need our English. We need our English, numbers, those things. Then what happens? There will be an interface between these two. So that interface we call it as the translators. That interface we call it as the translators over there. So which will do this business of converting from English to our translator, LATOR, translator. So now that translator will do the business of converting the formats, that is from English to our binary format 0 and 1, and 0, 1, 1, 1 to our knowable format English. So for that notation, for that conversion, we go with the standards called as the ASCII. So ASCII stands for American Standard Code for Information Interchange. American Standard Code for Information Interchange. So whatever we type, suppose if I type 0. So 0 ASCII value is 48 in the decimal and 30 in the hexadecimal. So how it will be stored? It will be stored as in the binary as a 0011 and the 0000. Fine. It is the hexadecimal notation what I used. 3 is 0, that is 30. Fine. So now it is in the binary. Fine. So that is whenever we type, so it will be converted to ASCII and that will be stored in the machine. But when we look at, so we won't understand that language. Of if I give the you as a 0011 and the 4 zeros, you may not get that that is the ASCII value for the 0. And how many characters as a human beings we can remember? Fine. So it is not possible for us to remember all the such possible combinations. So now to do that business, we normally use the translators. It will be used over there. Under the translators for the C language, you might have used the compilers you might have used, which will handle these cases. Fine. So along with the compiler, one more translator is there, interpreter, even that will do the same thing. Fine. That is internally it will be stored in the ASCII format. But when I open my application, suppose I open a text file And if I see my ASCII format over there, I can't get what the contents are, what they have written. So everything will be there in the zeros and the ones, which I can't get. Fine. So now when I open my file, I want my file to be displayed as in a format which I can understand. So what happens? Now it will be displayed in the, from ASCII to the character, it will be converted and it will be displayed. But what to do for the image file? So for the text numericals, it is fine. So image file, now when I shown you the image file, in the same thing happens if we are opening your exe file, that is executable files or the object file what has been created in your C program. So when you open up that one, now that is a format which we won't understand. That is it is for the mission to execute and shows the result. Results we can understand. But the intermediate executable file formats and all, we are not able to get. So for those formats, those files, they are stored in the binary files. They are stored in the binary files. The text files is the format which we understand. Fine. That is, a text file is also called as a flat file or a ASCII file. It is structured as a sequence of lines of alphabet, numericals, and the special characters. A data in a text file, whether numeric or non-numeric, is stored in the using the corresponding ASCII codes. And at the end of the file, we used to have a marker called as the end of the file. That is, we in the programming we call it as a EOF, which stands for the end of the file marker. Right? It is possible for the humans to read the text files which contain only the ASCII text. Text files can be manipulated by any text editor. They do not provide efficient storage. Why they not provide efficient storage? That's the question. Fine. So what happens is here for every byte we will have the storage. It is a byte by byte we used to have the storage. And in some cases we may not, it can be extended. Some of the bits can be extended over there. So that is, we may not be able to have the efficient usage over there. You may see that suppose in the first line I have written only till here. The left out blanks, it will be left blank space over here. After text and the binary files, if you look, the left out columns are blank. I am not making an efficient use of it. I am wasting my resource. I'm wasting my resource. If you look at the text files over here, so next to the text files, a lot of place has been left blank. It is a wastage of resource. We are not using the storage efficiently over there. Fine. But we need it because this is the format what we understand. This is the format what we understand. But when for the exe file and all, that is of no use for us, the contents. We just need the executable output. So in those cases, what we will do is we try to make the efficient storage. We try to make the efficient storage by filling all the columns and all the rows. But when we open that one, we are not able to read directly. We need a specific application which will open it and it will show us the result. Right? That is, if you summarize the text files, so text files are better for the human beings to understand, interpret, modify. But the disadvantage is they do not provide efficient storage over there. The storage wise, we are wasting most of the storage component over there. Right? So now the next category will be the binary files. If you go to the binary files, in the binary file, the data is encoded in a binary form, which is used for the storage in the computers and the for the processing purpose. For the efficient use, we go for the binary file. In the binary file, the text main is not broken up into the lines. That is, I shown one image file. So wherein we can't get what is the content of that file. We can't get the content of that file itself. And that is, with our bare eyes, we are not able to read those contents. But we are making the efficient use of the storage. Fine. That is, a binary file stores the data in a format that is similar to the format in which the data is stored in the main memory. Binary file is not readable by the human beings. Binary files contain the formatting information that can only certain applications or the processors can understand. Only the machine can interpret and it can understand. Binary files must be run on the appropriate software or the processor so that the software or the processor can transform the data in order to make it readable. The binary files make efficient storage of the data, but can be read only through the appropriate program. Fine. These are the two types of the files. One will be your text file, other is the binary file. So text file, what the human can understand, that will be your text file. But the storage is not efficient. The binary file we can't understand, but the storage is efficient. It is for the machine to store and interpret. Right? So this will be regarding the basics of your file type and its type of the files and the attributes of the file. The references for this video are taken from the textbook Ellis Horowitz and Sartasani, Fundamentals of Data Structures in C, 2nd edition, University Press, 2014. And Data Structures from the Sham Outline series, written by the Seymour Liptus, revised 1st edition, Tata McGraw-Hill, 2014. Thank you.